Okay, here I am. This is my first discussion here with AP Chemistry. Uh, when we left, we were going over different types of reactions and orders of reactions, and we did some graphing. And so, what I'm going to do right now is take a look at some problems related to first, second, or zero, first, and second orders. And if you have your book, we'll be looking at a page that gives us those reactions, and that's page 489. 489. And all we're looking at on these problems from this website, I got these from a website, was dealing with um, first order reactions. And so that's natural log of the concentration. So when we did our comparison, zero order was relationship between the time and the concentration. A first order should have been, and I didn't do it this way, so this is a change. A first order would be the comparison between time and the natural log. We've had it as the inverse quantity, but a first order, if you look on page 489, is a natural log. All right. And so then a second order would be looking at time versus the inverse of the concentration. So that being said, all of these are first order reactions. So if you look here, this is the equation on page 489. All right. So here's our problem. Here's the rate constant K. Here's our time T. And this is 1.48 grams remain at the end. That is going to be here natural log of A concentration. So that's what we're looking at, what's remaining. That would go in there. All right. So the second slide shows the setup. So this is natural log of the ending concentration. We can go ahead and use grams. Equals the minus K value. Here's K times T. Here's the time right here in seconds, plus the unknown, the natural log of the initial concentration. What's the mass of the original sample? So we plug that in there, and we go through the setup. We take the natural log of 1.84, and we get 0.610. That's going to equal the value of K times T, which is a negative 1.147, plus the natural log of the initial concentration, which we're trying to find. So then we're going to go ahead and add the 1.147 to the 0.610. We get 1.76 is equal to the natural log of the concentration, initial concentration. Well, now we're going to take the inverse log, which is the opposite button of the natural log button, which is E to the 1.76. And then that will give us the concentration of A. So the initial concentration is 5.81 grams. All right. What I'd like you to do is go ahead and pause this video and do this problem. All right. Now that you've done the problem, here is your setup. Again, natural log of A equals minus KT plus the natural log of the initial concentration. So on this one, we're solving for T, time, how many seconds. So we set up our equation, we rearrange it to solve for time, and we end up with 558,000 seconds. All right, so go ahead and look at that. Go ahead and pause it if you need to see if you got a different answer. Okay, here's the last one. Go ahead and pause it. Okay, and then here's the answer. So if you got any questions, we'll go over any of those questions that you have for me. I know this was quick. This was over 5 minutes, but those are 3 problems dealing with natural log, which is an order of 1. Okay, your assignment that I'm going to give you, you're going to need to do